Hi, welcome to Space Lunar Academy. This is Mr. Colosa, of course, and today we're doing video number 4 of the electric circuits exam revisions for grade 11 and grade 10. And if you're if you're doing grade 12 and you're watching this video, um, I'm assuming that you would like to understand the basics of electric circuits because this video is for grade 10 and 11. Okay, you can watch it if you want to understand the basics of electric circuits before you jump into the grade 12 electric circuits. Otherwise, it's the same thing, but there's just a little bit of a difference. It only differs on the part of EMF, where they say EMF is V internal plus V external, but we don't cover that part in this video. Because this is a video for grade 11 and grade 10, as I already said. Okay, in this video we're gonna be doing this question paper. This is a question paper taken from grade 10, the grade 10 question paper for physical sciences electric circuits. This is video number 4. It means that if you haven't watched the previous videos, first watch them, practice using the video. You can you can just take a book, take some notes, because as I answer these questions, I'll also be saying some important stuff, like telling you some important stuff related to current, resistance, voltage, and parallel and series circuits, or how to calculate resistance for parallel resistors. So that's what we're gonna be doing today. There's gonna be a lot more. I'll try not to move fast, but at the same time I'll try not to move too slow. Okay, let's try to analyze the circuit without wasting time. In the circuit below, the potential difference V1 across the battery and the potential difference V2 across the 4 ohm resistors are unknown. In other words, we don't know the voltage across this battery and we don't know the voltage across this 4 ohm resistor. Okay, that's what they are saying on the statement. Okay. Note that the switch as it's open is closed. It's open. It means there's no current flowing in the circuit. So in other words, if we place this voltmeter when there's no current flowing in the circuit, it means we will see the EMF. It means we will see the electromotive force of the battery. What is that? It means we will see the maximum voltage of the battery, before it is used by the circuit, because the circuit is currently not using the voltage of the battery. So if we place a voltmeter across the battery, we will see a reading of a total voltage that this battery will supply, maybe 12 volts. 12 volts would be the maximum amount of voltage that this battery will supply before it is even connected to the circuit, because it's not connected yet. There's no current. Switch S is open. Keep that in mind. Once switch S is closed, then this will no longer be 12 volts. It will drop. You see, this 12 volts is just a value that I made up, because we don't know. Remember, from the statement, we don't know the values of V1 and V2. Okay, hope that part is clear. I like to first analyze a circuit, or help you understand how electricity works before answering questions related to electric circuits. So we know that current, specifically the conventional current, is the type of current that we use in electric circuits. So conventional current starts from the positive terminal, which is the longer terminal. These long lines indicate the positive terminal. See, these two lines. But the short lines, they are called the negative terminals of the cells, or of the battery, in other words. So current which is conventional current, flows from positive, so it flows like this. What is current? Current is the rate of flow of charge. In other words, it is the flow of charges. In other words, we can assume it's water. So when it gets to this point, it splits. Some of the water gets to the side and some of the water flows to the side. It flows and passes through the 6 ohm resistor and comes back here, and some of the water flows and passes through this 2 ohm resistor, and then at this point it joins again. It becomes the same voltage that was, so the same current that got in, so it becomes that, and then it passes through the 4 ohm resistor without changing, because current in series resistor doesn't change, it remains the same. What are we assuming? We are assuming that this switch S is closed. That's why I'm doing this. I'm assuming that switch S is closed. It means there's current flowing in the circuit. So current will flow back to the negative terminal, and this will keep on going on and on up until there's no energy in the battery, up until we have no EMF in the battery. Okay, so that's how it will work. This is how the circuit will work, or the electricity will flow in the circuit. Okay, let's not waste time. Let's answer the questions. It is said that when switch S is closed briefly, the potential difference across the parallel combination of resistors is 4 volts. In other words, when this switch S is closed for a short moment, like a brief moment, assuming that switch S is closed, so that means there's a current that flows in the circuit. So it is found that we have 4 volts across these two. Remember, resistors in parallel have the same voltage. It means 6 ohm resistor will use 4 volts and 2 ohm resistor will use 4 volts. Both of these resistors will have the same voltage. Keep that in mind. Okay, let's not waste time. Let us not waste time. Then in V2, sorry, I don't know what I was saying or was trying to say. The first question, I was trying to read the first question. So the first question says, define the potential difference. What is the potential difference? The term potential difference. Okay, potential difference is what is the energy per unit charge that is flowing through it. That's how we define potential difference. I will explain it even further. 11.2.1. Potential energy, we can say potential difference, we can say in simple words, it is the work done per unit charge. Per unit charge, yes. So in other words, V, which is potential difference, because potential difference is voltage. It's just a word for voltage. Potential difference is the work per unit charge. Voltage is the work per unit charge, or potential difference is the work per unit charge. Or we can say potential difference is the voltage measured across an electrical component when current is flowing in the circuit. That is potential difference. Or we can say it's a voltage that is measured across a battery when there's current flowing in the circuit. It is, meaning we can say, or it is the energy in volts. It is the energy in volts, which is the voltage. Energy in volts measured. Okay, what did I just do? Okay, measured when current is flowing in the circuit. Let me try to explain that even further, because maybe some of you still don't understand what I'm trying to say. Remember, when switch S is open, it means when it was open, there was no current flowing on the circuit. So it means the voltage of the battery had an EMF. It means it had a total voltage. It was not connected to the circuit. It was just there connected, but there was no current flowing in due to the battery because the switch was open. Okay, so when the switch is open, there's no current flowing. So there will be an EMF, meaning a maximum amount of voltage. So if you buy a battery from the shop, let's say this is a battery from your shop. This is the positive terminal and the negative terminal. So sometimes it may be written 5 volts. That 5 volts is the maximum amount of voltage that this battery will supply to the circuit if it's connected to a circuit. So this 5 volts is called the EMF, that is the maximum amount of voltage that this battery will supply. But immediately once it is connected to a circuit, it means the moment we connect it to a circuit, let's say we connect to some bulb in a circuit, it will no longer become 5 volts. There will be 4,5 maybe volts. It means there is a decrease in voltage across these terminals. There is a decrease, and this decrease is due to this bulb because it's using this energy. So the voltage that is measured across these ends when there's current flowing, meaning this type of voltage that results after the battery is connected in a circuit, we call it the potential difference. Hence we say it is, okay, let's go back to the definition. Hence we say it is the energy in volts. In other words, it is the voltage that is measured when current is flowing in the circuit. When current is flowing in the circuit, we have potential difference, not EMF. EMF is the voltage measured when there is no current flowing. Hope it makes sense. Hope I've tried to explain it. Okay, keep that in mind, it's very important. Let's try to answer 11.2.2. 11.2.2, we are required to calculate the effective resistance of the 2 ohm and 6 ohm resistors. What is their effective resistance? Okay, let's take a look at them. The 2 ohm resistor and the 6 ohm, they are parallel. So we want the resistance of parallel resistors. Okay, that should be easy. That's 11.2.2. 11.2.2, 1 over Rp. Remember we said in the previous videos, when you want to find the resistance of parallel resistors, this is the formula that you use. 1 over Rp is 1 over R1 plus 1 over R2. So 1 over Rp becomes 1 over 2 plus 1 over 6, because those are the two resistors that we're dealing with. It's the 2 and the 6. Okay, let's not waste time. So that gives us 1 over 2 plus 1 over 6 gives us 2 over 3. It gives us 2 over 3. 2 over 3 is equal to 1 over Rp. So let's solve for Rp. If we want to solve for Rp, we cross multiply. Remember, those just maths. It's no longer physics, it's maths. Then solve for Rp. When we solve for Rp, we get 2Rp is equal to 3 over 2. Sorry, it's equal to 3. But we then divide by 2 on both sides because we want Rp. 2 cancels this one. Rp becomes 3 over 2, which is equal to 1,5 ohms. So 1,5 ohms is the effective resistance of the parallel resistors, which is 2 and 6 ohm resistor. So let's find the reading on V1, meaning voltmeter number 1. Where is voltmeter number 1? Voltmeter number 1 is the voltage, the total voltage of the battery. What is the potential difference across the battery? meaning V1 is the total voltage of the circuit. What is the total voltage of the circuit? What is the potential difference? Well, according to Ohm's law, we use Ohm's law to find that part. 11.2.3, yes, that's V1. 11.2.3. So to find V1, we use Ohm's law. According to Ohm's law says that I times R is V1, meaning it's the total current multiplied by the total resistance. Total current, do we have total current? Let's go and see if we do on the circuit. We don't. But we know that the two resistors, look at these two resistors. We know that these two resistors have a voltage of 4 volts. In other words, we can find the current that gets in here by multiplying the current of, by multiplying, dividing the voltage V over the resistance. That's Ohm's law. Let me write what I'm saying. We are saying that we can't find V1 because we don't know the total current, but we know the total resistance of the circuit. We can find it by adding this 1,2. We know adding this 2 get 1,2 ohms plus 4. That's going to be 5,5. 5,5 because it's 1,5. It's not 1,2. Let's go back. It's not 1,2. It's 1,5. So 1,5 plus 4, that's 5,5. Okay. So that is our RT. RT will be 5,5. Let's keep that in mind. 5,5 is our RT. So we have RT as 5, but we don't have I, so we can't find V1 in this way. We would have to first find the value of I total. I total is the same as V of the two parallel resistors, V of the parallel resistors over R of the parallel resistors. Why am I saying that is the I total? Let's go back and remind ourselves. It becomes the I total. The current in both of these resistors is the total current. Why? Because it came from the positive terminal and started to split between amongst these two resistors. So both of these resistors were combined have a total current. If we know the voltage, we can use them to calculate the total current. Okay, you will understand this if you have already watched the previous videos. But I'm guessing, according to the explanation that I started with, the analysis that I did before answering these questions, it should be clear that it makes sense. Should make sense what I'm saying. Okay. Okay, let's find this I total. So V parallel becomes, the V parallel is 4 volts. We're given to be 4 volts. 4 volts over R parallel. The R parallel is what? Is 1,5. We were given that. So guess what? We now know I total. I total is equal to 4 divided by 1,5. That's 2,67. Wow. It's 2,67 amps. This 2,67 amps is the current of the total current, meaning it is the current. Let's go back to the circuit and try to. This is 2, it means the current before it got in and in this branch, before branching out, it was 2,67 amps. Okay, I hope that makes sense. Now we do have the current, so it means we can use the current to find V1. 2,67 times R. What is R? R is the total resistance of the circuit, and the total resistance of the circuit should be 5 comma 5, or it can be, yes, it's 5 comma 5 because it's 4 plus 1 comma 5, which is 5 comma 5. So multiplying that 2,67 by 5,5, we should get 14,67. So 14,67 volts becomes our V1, the reading in V1. This is our V1. So it means that the battery originally, oh my god, it means that the battery originally had a voltage of 14, let's go back. Sorry for the delay, guys. I had to attend something of a matter of seconds. My PC was running out of battery, so I had to insert a charger. Okay, so we are saying that V1, meaning the battery originally had 14,67 volts. That's what it means. So out of 14,67, 4 of the 4 volts was used by these two. So it means for this one, if we want to find the voltage in V2, we can say 14,67 minus 4, then it means the remainder is for this voltage, this resistor. I hope it makes sense. If the total voltage is 14,67 and we use 4 volts for these two, so it means the remaining is for 4 ohm resistor, is for this 4 ohm resistor. Hope it makes sense. So if we want to find the reading in V2, this is the reading in V2. V2 should be 14,67 minus the 4 volts, which is equal to, okay, minus 4 volts, that should be 10,67. Yes, should be 10,67 volts. You see, that's simple. It's logic. It makes sense. It makes sense. If these two resistors use 4 volts of energy from the total of 14,67 volts, then it means the remaining energy should be used by that one, which is 10 volts, 10,67 volts. So it means resistors in series use more energy compared to those in parallel. Okay, so it's better to connect stuff in parallel than to connect stuff in series. I don't know, but I think so. It makes sense that way. Okay, let's yes, so we've calculated V1, reading in V1, which is 14,67 volts, and we just did calculate V2, which was 10,67, 14,67 volts. I hope this whole thing makes sense. I hope it does make sense. I'm sorry for delaying in some of the sections, but I didn't delay that much. I delayed when I was trying to insert the charger into my laptop because it was about to cut my video halfway, so I couldn't let that happen. Otherwise, this is all for this video. Everything is finished now. Yes, if you like the content, please click the like button and leave a comment and subscribe to the channel if you feel like this channel is helping you out. Thank you. See you in the next video.